ETL for the predictive analytics team, and today I'm going to talk about how to do that. So you're a developer, you've created your game, you figured out how to get a lot of people into your game, and now you have to try to figure out how to keep people in your game. So if your game is connected to Google Play Game Services, as users are playing your game, we're actually building very detailed time series of what users are doing in the game. So let's say that you have a game about killing zombies and farming. So here's a sample user in the game. He's acquired your game, he's gone and killed 100 zombies, he's farmed some stuff, he's farmed some carrots and tomatoes, raised sheep, he's farmed corn. But ultimately he's gonna end up leaving your game. Wouldn't it be fantastic if at some point prior to leaving your game, say like when he's raising sheep, you could get a signal from us that says, hey, this guy's about to leave your game. So instead of him leaving your game, you could say, well, I've got a golden shotgun. Maybe I'll give you like a 50% discount on this golden shotgun. So instead of leaving your game, he picks up this golden shotgun, and of course, with the golden shotgun, what are you gonna do? You're gonna go out and kill some more zombies. So this is exactly the type of thing that we're doing. If you go to the predictive analytics offering that we have, you can actually see examples of the time series of real people playing your games. And you can see that there's a huge diversity of events that show up in these time series. We've got session starts, any of the events that you define in your game, they show up, in-app purchases, we're working on integrating crashes and reviews, general RPC activity, just tons of stuff shows up in these time series. Well, what do we do with them? Well, we take a time series and we're gonna wanna feed it into one of our machine learning models. First, we're gonna need to extract some features from that, and I'll go into some details about how we extract those features. But at the end of the day, features for each one of these time series just boil down to a bunch of numbers. So here you can see I've got a bunch of columns of numbers. Each one of these columns corresponds to the features that we extract for one of the games. And historically speaking, we can look at the data so we know whether or not someone's churned or stayed in your game, so we can label each one of these feature sets, either green here for users that stay in your game or red for users that have left your game. We take all of the information that we have about your users and we feed it into Google's Sybil infrastructure. Sybil is a massive infrastructure that we have at Google for learning all sorts of types of classification tasks. It's used widely across all of, or many of Google's products, and now including analyzing how users are playing your games. So we take all of this data, we dump it into the Sybil infrastructure, and out comes a trained model. We do this daily, and then with this trained model, as a user is playing your game, we look at the time series for that user. Here we have the same time series that we had before. We extract features from it, and then we dump those features into the trained model, and that model is going to spit out whether or not we think that user is going to churn out of your game. So how do we do this? Well, in any of these classification tasks, one of the most important things is always trying to figure out how to come up with a set of features that represent your data points. Our data points are time series, and it's really important that the features that we extract out of this time series don't completely throw away the temporal information that we have. So how do we do that? Well, we define these temporal windows. Here I have an example of one temporal window. It's the one-day temporal window here. So we really have two time frames in this example. We have the one-day window, and we have everything that happens before that. Let's say in your game that you have an achievement called the Kill Megaboss achievement. If the user killed a megaboss greater than 1 day ago, then a particular feature gets turned on, this one that I have highlighted in red. However, if the kill megaboss happens before 1 day is up, then a different feature gets turned on. So we're preserving some temporal information in the features that we dump into our big bag of features. Now technically this is something that you could do on your own, although I'm not sure why you would since we're doing it for free for you. But one thing that you couldn't do is you couldn't look at what users are doing in other games. So just like we're building time series for users in your game, we're building time series for users in all of the games that they're playing. So let's say that this particular user is playing 3 games right now. He's playing your game and 2 other games. We can separate all of these games into temporal windows, 1 day ago, 2 days ago, 3 days ago. And we can look, for instance, at what's happening 3 days ago. Well, let's say 3 days ago, the user triggered 4 different events in your time series. But he was playing 2 other games, and in those other games, he triggered a total of 7 events. Well, these are just more features that get dumped into our big bag of features. And in addition to the features that we get out of our time series, we actually have a tremendous number of non-temporal features. Player demographics, mobile device, Android version, game genre, country, language, all sorts of stuff. And you can see now that our bag is getting really, really full of these features, but luckily Sybil can deal with a very large number of features. So in conclusion, if you want to get these type of powerful predictions from us, all you have to do is connect to our game services. The more signals that you give us, the better we can do. We currently have two models that we make predictions on, churn prediction and spend prediction. We're busy working to make improvements. We have two more models, big spender and lifetime value, and we're investigating other ML technologies that we have at Google, such as Google Brain and other neural network solutions. Thank you.